All right, welcome back to FaceTime with you. We are talking to one of our renowned experts here at the University of Utah, something that actually makes a lot of sense to talk about this time of year because the weather is always on our mind. And we're with Jim Steenburgh. He is the professor and chair of atmospheric sciences here at the University of Utah. And you have degrees both in meteorology and atmospheric sciences. And we were joking about this before we started here. That actually makes you a real weatherman.
That's right. Weather and climate. Cover it all.
So, what brought you to Utah? I mean, Utah obviously has some very interesting, unique challenges when it comes to climate. What brought you to the university?
Well, I'm a mountain weather guy at heart. I love the weather in the mountains, and so when I finished my doctorate, they had an opening here looking for somebody to just mount meteorology. So I was all over it like a wet blanket. Love to come to Utah. I'm a big skier too, so this is like a dream place for me to work.
So the atmosphere thing, not only in studying, but in actual being up there.
That's right. It's like my personal life is spent in the mountains. I'm either going to be hiking or skiing or mountain biking on the weekends when I have spare time, and then the rest of the time I'm thinking about mountain weather and climate.
So speaking of which, your time here at the U, you're obviously a professor, you do a fair amount of teaching, but when you're not teaching, what are you doing here at the university?
Well, I do a lot of research and mentoring of graduate students. So right now I have 4 graduate students that work in my program, and they're all doing work that's related to the meteorology of the western United States. One of the projects we have right now is sponsored by the National Science Foundation, and we're looking at lake effect storms produced by the Great Salt Lake. And in the past we've worked on winter storms throughout the west, sometimes these cold fronts that form and produce high wind events, for example. And we do a little work on dust transport as well. So we're looking at dust and how it gets deposited on the snowpack of the western United States.
Yeah, speaking of the snowpack, we every now and then we have questions come in when I tell people who we're going to be talking to. Utah claims to have the greatest snow on Earth. What is it about Utah's snow that makes it the greatest snow on Earth?
Well, it's not anything special about the snow. It's how much falls, which is a lot, and how it falls. So during our winter storms, we have a lot of storms that start off relatively warm, and then they get colder over time. And this produces snow that's a little bit denser and heavier to start and gets lighter with time. And that's what you want for ski flotation. So the skis really float very well through the snow. That's what I call. That's the true secret of the greatest snow on Earth.
Now, Utah does have a very special climate as well. We see things on the news all the time that kind of tries to explain to us why we have such interesting, extraordinary weather. Something called the lake effect. What exactly is the lake effect, and what does that do to our community?
Well, the lake effect is basically either snowstorms or rainstorms that form because of air moving over the lake itself.
Okay, so these aren't storms that move in from other parts of the country or are blown in from the northwest, or so to speak. They actually are created here.
Well, the cold air might originate over the Pacific Northwest or over the northern Pacific Ocean, but basically you wouldn't get the storm normally without there being a warm body of water there to inject some heat and some moisture into the system and get it going. Some storms are what we call lake enhanced, though, so there'd be snow or rain falling anyway, but the lake gives you a little more juice to get the storm over the top.
Now, in Utah, again, very interesting climate here, but we've had an interesting winter here. We're talking here maybe getting closer. We're in February of 2011, and we've had a lot of cold in Utah. Of course, a lot of the country's been seeing that. Are you surprised by the weather we've had this winter?
I think it's been quite cold in terms of the recent climate. And in Utah, I don't think we're anywhere near like Arizona. I mean, Tucson had incredibly cold temperatures. They had the lowest temperature in Tucson since 1899, a week or two ago, which is pretty incredible. On the other hand, when you look at the United States as a whole, there's a lot more high temperature records being set. About 2/3 of the temperature records being set today are high temperature records, and about 1/3 are cold. So with a warming climate, it doesn't mean that you can't have a cold spell or you can't have a cold winter, but what it means is the dice are loaded. It's like going to Vegas. You're much more likely to have an unusually warm season than a cold season. But the ups and downs of the jet stream sometimes give us a cold period.
So does that bring any interesting challenges to you when it comes to predicting the weather? I mean, you mentioned before, Utah does have a lot of ups and downs, and I've lived here for decades, and I'm never surprised at a snowfall in June or a 75-degree day in February, which isn't really surprising for us. Does it make it more difficult to predict weather here?
This is one of the hardest places in the United States to forecast the weather.
And why is that?
There's a number of reasons. It has a little bit to do with the fact that a lot of our storms are broken up by all the upstream topography. So you have the Sierra Nevada and the Cascades, and they kind of chew up these storms. So instead of having these nice big systems that cover an area of several hundreds of miles or maybe even 1,000 miles, they're all chewed up into little bits and pieces. And getting the timing right for when those bands of precipitation are going to come through is very challenging. It makes it a little more difficult. So that's one of the big reasons. Another reason is that in the spring around here in particular, when a storm, it slows down a little bit, we get very warm, and then it comes through, gets real cold, so we get these large swings in temperature, and that's also another challenge to make things a little more difficult. But we know our computer models do worse here than anywhere else in the United States.
Maybe that's why people come to you all the time and want to know. It seems like there's a lot of national focus on the Mountain West when it comes to weather.
Yeah, but I'm no magician. I mean, I know a lot about the weather here.
So you can't change the weather.
No, and our computer models are really the basis for how we forecast the weather. So if we want to have better weather forecasts in the future, we really need to get these computer models better for the state of Utah.
Well, and that's one of the reasons why you came to Utah. I can see now why you think it's so exciting here, and it's such an interesting weather climate. And we also have obviously the university, a research-minded university,
yes,
allows you to be able to play in that field as well.
That's correct. And during the 2002 Olympics, for example, we ran a specialized computer modeling system for the 2002 games, and we were able to run it on really big computer infrastructure that we have here at the U.
That's great. Well, Jim Steenburgh, a very busy guy here. He is a real weatherman. Thanks for talking with us. He is the professor and chair of atmospheric sciences here at the University of Utah.
It's easier to say than
I know it is, yeah, and it's a lot easier apparently to sit and talk with you than do, because I'm just watching the maps and everything in your office here. It's really interesting science.
Great.
So good luck to you, and we'll be back with more FaceTime at a later date.